I said in part 1 of this series that an eBay seller was selling a heat sink which would mate perfectly with this section here. And that jogged my memory. After I ordered a couple of these, I realized I already had them, or one of them, here in the building. So I dug it out, and I will begin assembly of the heat sinked components. There are 3 of them. A 24 volt 3-terminal regulator that's used to supply the optional fan, a 5 volt 3-terminal regulator that provides 5 volts for the Atmel chip and the LED display. These heat sinks came with the components. This heat sink costs a little less than $5, and I doubt that it can be used on here without a fan. I have a hunch that with the fan, it's a 40 millimeter 24 volt fan, it'll have enough thermal capacity to work almost at 50 watts, which is the worst case condition for this power supply. I'm going to not use an insulating barrier on these. However, I am going to put an insulating heat transfer pad on here. And for this, we always need to be careful to make sure we use heat sink paste. Now here's a situation where a little dab will do fine. This is a Radio Shack 24 volt 2 amp transformer. Well, it's 12.6 times 2. It has two 12.6 volt windings, and it's rated at 2 amps. Right now, with no load and without a control board on it, it's producing 28 volts. Assume this fellow's ground. And the output from the 5 volt regulator is 6.3 volts. So it's a 1.3 volts high. I'm not too happy with that. Now the 24 volt regulator shows an input of 37 volts, which is probably this voltage full wave rectified. The output of the 24 volt regulator is 24.044. So I think before I go any further, I may just replace this 5 volt regulator. Replace this 7805. And now the 5 volt rail is 5.06, which is a lot more to my liking. So this is the test setup. I've elected to use a 50 by 50 by 15 millimeter fan, and I don't have any 24 volt fans. So I put a 12 volt fan here, and I'm powered it up from a remote power supply. This thermal switch needs to be mounted. I need to find out a way to do that. The preferred way was to mount it on the side of the heat sink and hold it with a binder clip, a paper clamp. I can't do that with this situation. And it's operating right now with no load. I'm going to rotate the voltage knob, and you see each click is 1/10 of a volt. But if I turn it fast, I think the same thing will happen with the ammeter. Now I supposedly can push this button and set the voltage at 12. And if I push the green button, I'll set the current at 1 amp. I'm going to power it down now. Power it back up. And it retained the settings. That's not bad. I'm going to hook my load up. I don't know what current my load is set to draw. It's obviously trying to draw more than 1 amp because the voltage folded back and this current is right around 1 amp, which is the limit. Here we are with a setting of 24 volts and a current limiting output of 2 amps. The dummy load is drawing about a perfect 1.5 amps. And the indicated draw, you can see it looks like 1.5 amps, but it bounces around considerably. The output voltage is on the load claims to be 24 volts. Well, that's good. Now let me crank the load current up. You can see it going up here. I may be dropped off 1/10 of a volt, but that could be in the resistance of the leads and connections as I increase the current. Voltage here is still indicating 24 set and 24 supplied. Now as soon as I run over 2 amps, see what happened? It folded back. I'll decrease the load, and there we go. The load came back below 2. The voltage went up. Let me turn it down to 10. I'll reinstate the 1.5 amp load. The bench meter indicates the output terminals are set at 9.99 volts. Although this is jumping around, it's close enough to 10. We still have our current. If I increase the dummy load current, we'll see it begin to go up as we reach 2 amps. An asterisk appears, the letters overload, and the voltage has not yet folded back, but I'll go a little more, and the voltage folds way back. All in all, except for this voltmeter jumping around like this, the power supply seems to do exactly what it's supposed to do. The ambient temperature in this room is about 24 degrees Celsius. Looking at the securing screw on the heatsink, I'm reading about 45.9 Celsius. Looking at the black body of the transistor, this is what I come up with. Now the screw terminal, it comprises the output voltage. Once you solder it in place, you can still read the plus and minus. The fan, however, once I solder that socket in place, it obscures the plus and minus markings. So I've lost the fan. It can't be true. So I've taken the option of painting the positive side of the fan jack red, because once I plug it in, once I secure it to the board, it will be unreadable. So the output measured here with the bench meter reads 4 volts, which is what it's set at. The power supply, the dummy load is drawing 1.88, which could be what that says. I've taken this little temperature sensor and sandwiched it between this copper strap and the heat sink. Now I'm not sure that this thing just doesn't start and stop the fan, but not having some 24 volt fans, I can't really find that out. Well, this thing is run for about 4 hours. I can't touch the transformer. I don't want to touch the heat sink. It's been running a little less than 2 amps. And it's probably dropping at least 22 volts. So 22 volts drop, and that's just a guess. Almost 2 amps of current. That's a total dissipation of 44 watts, which is not, take a 44 watt lamp and hold your hand on it after an hour or so. Well, after 3 minutes. So we'll look at the temperature. The pass transistor. This is in C. The Radio Shack transformer. The 7805. So at this point, I'm going to shut it down and move all this stuff into a case. Once I get my final fans, I think I'm going to use 2 fans, and my final knobs, I'll do another part where I show this thing in its enclosure with the enclosure completely finished. So if you've enjoyed this, or at least if you stuck by to see the end of this, please subscribe, leave me a comment. Thank you.